I have an L, I have an R, I have a C, and I have an E0 cosine omega t. This is 110 ohms, and you're being told that the impedance is 150 ohms. And you're being asked, what is the mean power that is delivered to the circuit? I have to say mean, because I have to average it over one complete cycle, one period of oscillations. Because as you will see, the power delivered to the circuit is not constant. It oscillates. I think it oscillates with omega squared, some kind of sine square omega squared, but you figure that one out. In any case, the mean value equals the voltage RMS times the current RMS times the cosine of that angle phi, the way I defined that before, and I will refer you to equation 3230 without any further elaborating on why this is so. Now VRMS is obviously IRMS times Z for the simple reason that V0 equals I0 times Z. That's the way it is defined. This V0, by the way, is that E0. And the tangent of phi, which we have mentioned many times, is omega L minus 1 over omega C divided by R. So, you shouldn't have any difficulties calculating these values because you know the VRMS, that is the V0 divided by the square root of 2, and you know V0, and you know Z. And so you can clearly calculate IRMS, so you know this one, and so you're almost there as long as you can calculate cosine of phi. How can I convert this into a cosine? Well, that's a trick that I already learned in high school. I have here a triangle whereby this angle equals phi, and I know that this is omega L minus 1 over omega C, and I know that this is R, because the tangent of phi is exactly what we gave before. That means this here must be the square root of omega L minus omega C squared plus R squared. But that is exactly Z. And so the cosine of phi equals nothing but R over Z. Since C was given and since R was given, you can find the cosine of phi, which I believe is 0.73. So it's very easy to go from tangents of phi to cosines of phi.